Dear friends, welcome to Civil Conclave presentation. Today we are going to discuss about what is structural engineering and what are the drawings it consists of. A brief. Structural engineering and drawings. Structural engineering is consists of footings, columns, beams, slabs. PCC. The plain cement concrete consists of cement, sand, and aggregate mixed in the correct proportion with an addition of the water. The picture of the PCC has been shown adjoining to the images. It is used as a protective layer for the RCC above so that water from the RCC is not absorbed by the earth below. And also it provides a base for the concreting and also helps the workers to set out the structure above in an easier way. Function of a PCC. It's act as a cover to the reinforced cement concreting, that is, resist corrosion of steel bars in footings. Moisture which is available in the soil should not absorbed by the RCC footing, which will cause the corrosion in the reinforcement. The maximum size of the aggregate used in PCC is 40 mm. The depth of the PCC depend upon soil bearing capacity of the soil. It should be at least a minimum of 150 mm thick bed. It might be contained in the ratio of 1:4:8, 1:3:6, and 1:2:4 when you use in the volume concreting. Footings. Footings are the structural members which used to support the columns and walls, which will transmit and distribute the load to the soil in such a fashion that the load bearing capacity of the soil is not exceeded, excessive settlement, differential settlement, rotation are prevented, and adequate safety against overturning of sliding and maintained. Wall footings. The wall footings are used to support structural wall that carry the loads for the other floors. See, this is the image of the wall footing, which has been shown. The footing and the wall, which is known as a wall footing. Isolated single footing. Isolated or a single footings are used to support single column. This is one of the most economical types of the footings, which when it is being used, the columns are spaced at a relatively long distance. Here you can see the images of the various isolated footings or a single footings. See, this is a side photographs of the isolated footings. Combined footing. Combined footing generally support two columns or three columns. Combined footings are used when the two columns are so close or that a single footing cannot be used. Okay. When one column is located to the nearest property line, etc., etc., that is the time the combined footings are being used. Here you can see the combined footings, which is in the plan, okay, and it is in the elevation. The use of combined footing helps spread out the loads to the adjacent footing in order to minimize the stresses in the footing and reduce the differential settlement between them. See, this is the image of the actual image of the combined footings at the site. Cantilever or a strap footing. This consists of two single footings connected with a beam or a strap and a support two single columns. This type replaces a combined footing and is more economical. Here you can see how the strap footings have been created. See, this is in the plan. Here you can see the two footings. There is a strap beams. Here this is in the elevation, column, strap, and footings. Okay. Continuous footing. Continuous footings support a row of three or more columns. They have limited width and continue under all columns. Here you can see the plan of the continuous footings and the elevation of the continuous footing. Raft or mat foundation. This consists of one footing, usually placed under the entire building area. They are used when soil bearing capacity is very low and different settlement must be reduced. See, this is the image of the raft footing where there is a one single footing and various columns have been coming down from the raft footing. Pile caps. Pile caps are thick slabs used to tie a group of piles together or to support and transmit column loads to the piles. Here you can see the pile caps in the plan. There are pile. This is known as a pile cap. This is a column. This is in the plan. This is in the elevation. Column. Columns, these are all called vertical members. This supports loads from the beams and the slabs. This may be subjected to axial load movement. Starter for a column. How to do a starter for a column has been shown in this image. Here you can see the column image. Plinth beam. In the frame structure, plinth act as a tie, as a beam at a ground level itself. RCC plinth beams are being recommended for the earthquake resistance property. 4 inches to 1 feet thick plinth beam is a concreting beam sizes. Plinth beam is a reinforced concreting beam constructed between the wall and its foundation. Plinth beam is provided to prevent the extension of cracks from the foundation into the wall above when the foundation suffers settlement. See, this is the image of the plinth beams, which has been shown here. While the concreting is going on, how the plinth beam concreting has been going on, that also site images have been shown. Loads. The building dead load is the only known node. All other forces vary in magnitude, duration, and location. The building is designed for design load possibilities that may never occur. Beams design. Beams are used in floors and roofs. May be called as a floor joists, stringers, floor beams, or a griders. Loads on beams, either concentrated or uniform load. Beams designed for shear moment and deflection. This is the methodology of a roller support beam, which has been shown here. This generally happens in the big bridges and other places. This is pin and hinge supports. How we do the pin and hinge supports in the girders has been shown. Cantilever beam. This is the image of a cantilever beam at the site. You can see this all generally happens in the petrol pumps and other areas. Beams. Beams is a horizontal member of a structure carrying transfer loads. Beam is a rectangular in cross section which carry the floor slab or the roof slab. Beam transfer all the loads, including the self weight of the columns and the walls to the foundation. Here you can see the images, the load, which has been the compression. This is a natural action resistance. Reinforcement of the simply supported beams has been shown here clearly. RCC beams. These are subjected to bending moments and shear. Due to the vertical external load, bending compresses to the top fibers of the beam and elongates the bottom fibers. That means the reinforcement. The strength of the RCC beam depends upon the composite action of the concreting and steels. Load acting on a structure. There are various loads. Let us talk about a dead load. Dead load is a self weight of the various components of the building, that is such as a brickwork, concreting, columns, beams, etc. Live load. This is an external superimposed load on the structure. Live loads may be uniformly distributed, uniformly varying load, or a concentrated load. Types of the beams. There are various types of the beams: simply supported beams, fixed beams, cantilever beams, continuous beams, and overhanging beam. Simply supported beam. You can see this image, which will clearly explain you what is a simply supported beam. The beam supported freely at the two ends of the wall. In actual practice, no beam rests freely on the supports, walls, or a column. It has been entered into the beam. Fixed beam. Here you can see how the fixed beam has been working on it. In this beam, both the ends of the beam are rigidly fixed in the supports. Main reinforcement and stirrups are also provided. Cantilever beam. It's a fixed in a wall or a column at one end, and other end is free. It is called as a cantilever beam. It has a tension zone in the top side and the compression zone at the bottom side. Okay, here you can see the image of how the cantilever beams works around. Continuous beam. It is supported on more than two supports. This beam more economical for any span length. Here you can see how the continuous beams works. RCC beams, they called as singly reinforcement beam, doubly reinforcement beam. Singly reinforcement beams only at the reinforcement of the bottom, whereas doubly reinforcement bars are both top and bottom, which is being tied with a stirrups. Loading on beams, concentrated load, uniformly distributed load, uniformly varying load, and arbitrary loading. These are all the loads which acts on the beams. See, this is a concentrated load where exact one location. UDL, uniformly varying load, because it will depend upon these things. This is arbitrary loading. Okay, this is the methodology of how to calculate the loading factor. Columns. Columns generally carry the axial loads and therefore designed for a compression. Additional loads when there is a snow location or horizontal forces can cause bending in the column. Columns then need to be designed for axial load and a bending. Columns is a vertical structural member. It transmits the load from the ceiling, roof slab, and the slab. That is inclusive of its self weight to the foundation. Column may be subjected to pure compressive load. RCC columns are mostly widely used nowadays. Type of columns: long columns, slender column, short columns, and intermediate columns. Here you can see the RCC columns of square, rectangular, and all these things have been shown in these images. Lintel. Lintel is a support beam with its ends built into a wall. It's a horizontal structural member placed over a small opening such as a door, windows, ventilators, cupboard, etc. Classification of a lintel. Lintel might be a timber lintel, stone lintel, brick lintel, steel lintel, and RCC lintel. Here you can see the image of how the lintel beam has been provided in things has been shown very clearly. Thank you for watching this presentation. If you like this presentation, kindly subscribe, like, and share, which will motivate me for a further good presentation. In case of any queries, do not hesitate to write to me. The response will be at the earliest. You can contact me at civilconclave@gmail.com or at my Telegram group, for which the link has been provided below. Thank you for watching this presentation. Kindly subscribe, like, and share with your friends. Thank you once again.